some of these exercises, generating solutions for these exercises. Now these are generally all going to be about projection, in other words, getting particular columns from the table. So let's look at the first one, which says display all the information in a table called grade. Now we'll start off by doing that in relational algebra, and if you think about it, that's going to be particular columns that we're interested in producing. So we're going to use a relational algebra expression that looks like this. So we'll start off over here on the right hand side, and we look at the particular thing we're trying to work out, and it says all the information in the table called grade. So the name of the table, the name of the relation goes between the brackets. So in here it's simply grade. Grade goes inside the brackets, and then outside the brackets in a subscript we put the names of the particular columns that we're interested in, and this says all the information in the grade table. So there are 3 columns, so it would be grade, low sal and high sal, like that. There we are. So reading that aloud, what it actually says is we are going to project particular columns from the table. Which particular columns are we going to extract? It would be grade, low sal and high sal from the grade relation. Now in fact there is actually an easier way of writing that down, because what we're really doing is we're getting the entire contents of the grade relation, of the grade table. So we could just actually write grade, that would be equivalent. So what would that look like in SQL? So let's go back here. Now I've got my SQL database already loaded in, so if I click on create and I go into query design, and I'm going to go into the SQL mode, and the 3 words that we use for the majority of our SQL queries are select, from and where, and I like to lay them out on separate lines like that. Now these are introductory exercises and they're all going to be about projection, so in fact we're not even going to be using where today, so I'm just going to delete that. So the first thing I do, very similarly to the way that I approach writing the relational algebra expression, is to think about what table or tables am I going to be pulling information out of. And I know it's going to be the grade table. So grade goes here after the from reserved word, and on the top line we place the particular columns that we're interested in, and those columns are grade, low sal and high sal, like that. And now I can click run, and there are our 3 columns: grade, low sal and high sal. Now it would be irritating if we wanted to see all the columns, if we actually had to type all the column names over and over again. So SQL gives us a shortcut, and the shortcut for show me all the columns is the star, like that. So I can go select star from grade, and I can click run, and there we are, we've got all the particular columns. So that's the first exercise. So let's just reset that. Let's have a look at the next one. Next one says show all the people, so in other words their names and their hire dates. Now oops. So here we go. I'm just going to take something like this and pop it up the top. So we want the names of the people and the hire date. So we just follow that process again. First question is, which particular table are we working on? And in this instance, we're working on the emp table. So emp goes in here. And then outside the brackets, in subscript, we write down the particular columns we're interested in. And in this instance, we know that we're looking for the ename and the hire date, the name of the people and the date that they were hired. So we go ename and hire date, just like that. Let's do it in SQL. So again, we start off with our words, select from, and we're not going to be using where today. So the first question is, which particular table contains the information that we're working from? And in this instance, it's going to be the emp table. So we just put emp there. And then after select, we put the column or columns that we're actually interested in. And in this instance, it's going to be ename and it's going to be hire date, like that. So I can run that. And there we are. We've got the ename and we've got the hire date. So back to the SQL, and I'll just blank that out. Let's have a look at the next one. Display all the different types of jobs. Now, to do that in relational algebra, we know that the job column is in the emp table. So start with the relation, start with the table name. What's the name of the table we're working on? It's going to be the emp table. And the name of the column we're interested in is simply, in this instance, job. So there we are. There's the relational algebra. Show me jobs from the emp table. So let's go over to here and let's do the SQL for that. So we go select and we go from. The name of the table that we're interested in is the emp table, and the particular column we're interested in is the job column. And when I run that, we get that. Now, here is a significant difference between the model, the relational model, and the way that databases implement the model. Because the relational model is based around the concepts of sets and relations, when we do a projection of job from emp, what we actually get is this unique set of jobs. So we can see admin, analyst, manager, president, sales. But of course, this is an implementation of that model in a piece of software. So when we say, show me all the jobs, Access, and this is the same for all databases that are implemented like this, it shows you, literally does show you all the jobs. If we want to see specific, unique, distinct jobs, we have to use that reserved word distinct. So if I go back into SQL, what I'm going to do is I'm going to attach it. I'm going to just insert it up here. And what that's actually saying to me is, don't show me every single job, just show me the unique jobs that we have. And if I run that now, we just get the 5 jobs like that. Okay, next it says, show a list of all the people along with their monthly earnings. And of course, the way that we do monthly earnings is to divide the salary by 12. So let's do the relational algebra for that. So again, nip at the top. So all this information is in the emp table, the emp relation. So the name of the relation, or the name of the table, goes in here. And so it's the emp table. And what we're interested in, what we actually want to see, what we want to extract from that table are 2 columns. We want to get the ename and we want to get the salary divided by 12, like that. So let's do that in SQL. So if we go back to here, go back into the SQL. again, start off with the select and the from, like that. So which table are we working on? Well, we know it's all going to come from the emp table, so we just put emp after the word from. And we want to see, so it was actually, we wanted to see the names of the people and their salary divided by 12. So that's going to be the ename. Now sal will just give us the sal column, but in this instance we want to divide it by 12 to give us the monthly salary, so it looks like that. Now if I run that, there we are, we've got ename and we've got salary divided by 12. But of course in SQL what we can actually do is we can rename a column so that we don't end up with things that look like this expression 1001, a kind of semi-randomly generated column name. And the way that we do that is by using the reserved word as. And you can use any name you like as long as it doesn't begin with a number and it doesn't have a space in it. So for example, we could call it monthly sal, like that. And if I run that again, you can see it's actually, if I just widen that column a little bit, you can see we've got ename and we've got monthly sal, just like that. Okay, next one, show me a list of locations where departments are located. Now this is in the department table and we can see that if I just bring the department table up. Here we've got a location column in the department table. So back to here. What's the name of the particular table that we're interested in? It's going to be the department table. And which particular column we're interested in, columns or columns? Well, in this instance, it's just the location column, and that's called loc. So that's how we write it down in relational algebra. In SQL, so I'll just delete this again, select from. So the first thing, I always think, what's the particular table or tables we're interested in? It's the department table. And what's the column or columns we're interested in? It's the location. And this is an example of where it's really important that you get the column name right. It's not location, it's actually the abbreviation loc. So if we run that now, there we go, London, York, Birmingham, Leeds, just like that. Show the grade and a difference of 12% rise in the low-sal figure would make to each grade. So let's do the relational algebra first. Now in this instance, the first question is, which particular relation or table are we looking at? Well, it's going to be the grade table. And we want to change the low-sal figure. What we're going to do to the low-sal figure, it says, is we're going to increase it by 12%. Now an easy way to do that is just to go low-sal times 1.12. That's an increase of 12%, a 12% rise to the low-sal figure. So if I was to read that aloud, I would say we project the low-sal times 1.12 from the grade relation. Let's do that in SQL. So the name of the table, it's the grade table, and we're going to project the low-sal column. So if I just run that, we just get the low-sal column, but what we actually want to do is we want to change the low-sal value. So we're going to multiply it by 1.12. Increase it by 12%. Again, we run that. Here it is. But again, we've got that sort of semi-randomly generated column name, and the original question actually asks us to name it as increase. That's where we use that reserved word increase. So we go reserved word as. We go as increase like that. Click run, and there we are. increase by 12%. There's the SQL. Now the final exercise brings all of this stuff together, and it says show employee name and number as a single column separated by a hyphen, along with what difference a 5% increase in salary would make. So let's do the relational algebra first. So we are going to be working from the EMP table. That's where all that information is. It's going to be the EMP table. And on the outside of this, we will be using the employee number, the employee name, and the salary. So back in the EMP table, if I just bring it up, it will be using EMP number, ename, and sal. So in here we're going to have EMP number, ename, and sal. But we're going to be combining these in a slightly different way. So EMP number is going to be concatenated onto ename, and we're just going to use the ampersand symbol. There isn't really a way to do this in relational algebra, so we're just going to reuse the way that we do this in Access. The way that this would be done in SQL, in the SQL standard, is it's not the same as this, but we'll just use the ampersand. It doesn't really matter, just to give you an idea. So we'll combine EMP number with an ampersand and with ename. So that will give us our first column, if you like. EMP number combined with a hyphen and then combined with ename. And we're going to do some maths on sal because it says increase people's salary by 5%. Now remember, this is the equivalent to a what if question because we're not actually altering the values in the EMP table at this stage. So we're going to do an increase of 5% on sal, so that would be times 1.05. Not times 1.5 because that would be a 50% increase, times 1.05. So that's how we would do it in relational algebra. Let's do it in the SQL. So I'll just delete this, go back to where we were. First question then is always which table or tables are we interested in? We're going to be using the EMP table here. So I just put the word EMP after from. And we know we're going to be using those columns. We're going to be using EMP number, ename, and sal. EMP number, ename, and we're going to be using sal. What are we going to be doing? Well, EMP number is going to be combined with a hyphen and is then going to be combined with ename. Now that's called string concatenation. And that's the string concatenation operator that's used in Access and Excel. So we're going to take EMP number and we're going to combine it with a hyphen. Now this is a string, which is why it's wrapped up in double quotes. A string is a series of characters. So we take EMP number, we combine it with a hyphen, and then we combine it with ename. So that's going to be our first column. And then we've got sal. What are we going to do to sal? Well, we're going to increase it by 0.5%. So we go times 1.05. Now what's nice is we can actually try this out to see if it works. So I go in here and I just run it, and that's the data output that we're looking for. The final thing we can do is these aren't particularly nice column names, so we can go back into the SQL and we can put a couple of as statements in here to rename these. So this one we could, I think it's called employ, literally just names that are being made up, and this one is going to be called new cell. So remember the naming policy here, it mustn't begin with a number and it mustn't have a space in it, but that's fine. I mean, in fact, you can put spaces in and there's a way to make that work, but let's just keep it straightforward at the moment. So no number at the beginning, no spaces in the middle of the name, but you can choose whatever name you like, and then you run it And here you have employee and new cell, two columns that we formed from the emp